This recording is for Primary Math 1, looking at the challenging word problems, pages 13 to 17. Generally, I always want you to look through the example problems with your child or work them with your child before you start the word problems. But I'll tell you what, example 2 is a lot of words and a very interesting way to show it. I will show it to you a little bit differently. And as always, there are lots of methods to work math problems, and you can work those in different ways, but I'll do that one when we get to some of these problems that we're going to solve similar to that. First, though, number 1 shows a bunch of trees. I drew triangles instead of trees, but the idea, keep the picture here, 10 is being divided into 2 spots. So although it looks a little bit odd, and doesn't look like the number bond in the traditional style, we see that it breaks down to 7 and 3. And then they have the 7 breaking down into 2 spots, and so I know that that is going to be 6 and 1. And then the 6 is coming down into 2 spots, and I know that's going to be 5 and 1. So as we work through it, it actually turns out to be a pretty straightforward solution. 5 breaks down into 2 and 3, and 3, I didn't mark this one down, this one is given to us to be 1. 3 breaks down into 2 numbers, and that would be a 2 and a 1. And this time they don't give us either of those numbers, and so we have to decide all by ourselves if we're going to put 0 and 2, or 1 and 1, or 2 and 0. Any of those answers, of course, will complete the problem that we have. Number 2. This problem, number 2, is a bit of an interesting one. It leaves me with some unanswered questions that we can figure it out easily enough, but like, for example, I don't know why they didn't draw these. I don't know if that was just a mistake they didn't see, or if they purposely left those 2 green lines off. They didn't put it in the drawing. Not sure why, but it works the same with everything else that it has. It seems to me, but those are not on the list. The hint also tells you to look for relationships before finding missing numbers. So for example, 3, 4, 5, one could presume that a relationship would be that that one might be 6. If you look at this triad of numbers, 4 and 5 is 9, and 7, 9 makes me think of 11 is next, and in fact 5 and 6 does make 11, but they didn't put this line here. Not sure why they didn't do that. And then we can see that 7 and 9 make 16, and 9 and 11 make 20. So each of these numbers I'm adding 1. Each of these numbers I'm adding 2. This number from 16 to 20 is a difference of 4, which I guess you'd have to be thinking square numbers. I was thinking square numbers, but that's not really a first grade concept to see the correlation of those. Anyway, it's an interesting puzzle. 20 and 16 do add up to be 36, and so that fits in with the 36. And so we have some triads that work. The 9 and 4 are a triad that work. The 9 and 7 make 16, and the 11 and 9 make 20, and these 3 come together. So these numbers, nope, not that one. These 4 numbers are all numbers that they have listed that seem to show that they add by the numbers below them. But in fact, although they don't show it, it seems to me that this number and this number do as well, except they didn't draw the line. So I'm not really sure. It may just be some kind of a misprint. Maybe I'm missing something in how they're showing it. Not a big deal. That's how they fill it in. It's all good. Number 3. This problem shows that the wagon itself is named by the sum of the 2 wheels in each of these cases on this sample one. And so then it gives us a harder one to do. And again, these just get harder and harder and ask us to handle more and more numbers. Again, what I said in a previous recording is that we really are trying to think of doing things in a methodical way and an organized way so that we can find the answers. It tells us that there's only one solution. How in the world would we know where to start to find it? And I notice the fact that this train is a 1 and that tells me I either start with a 0 and have a 1 next, or I start with a 1 and I have a 0 next. If I start with a 0 and I have a 1, then this number has to be 7 in order for 7 and 1 to give me 8. And then for 7 and this number to give me 7, I have to have a 0. And for 0 and the next number to give me 6, I have to have a 6. And so this set of numbers works: 0, 1, 7, 0, 6. And the problem told us there's only one solution, so it sure seems like we found that one solution, but I would have to be curious. How come the other one doesn't work? Let's try it out. If 1 goes first and 0 goes next, of course that goes up to 1, which is the train is 1. If I have a 0 and a number that has to get up to 8, then I have to put an 8 there. And here's where the problem is. 8 and something has to give me 7, and I don't have the ability to put a number in that box that's going to give me 7 if I'm already starting with an 8. So that's why this solution won't work. There's only one option, and it only works if you put a 0 in the first train. Number 4. This problem tells us that we have, in the hint, it explains that the wheels are added. If you add the wheels up, you get the rectangles between them, and we have a part A and a part B to solve. And these are not simple problems in my mind. I think sometimes this will be something you can kind of begin to see how intuitive your child is with numbers, things like that. But I wouldn't be too concerned if you have to guide your child through these kind of things. And yet again, what we want to do is show them how to methodically find a starting point that will help a problem out. Here's what I realized when I was thinking about this. These two numbers add up to 5, and yet these two numbers add up to 6, but they have one number in common. So when I made a list of the numbers that add up to 5, and I made a list of numbers that add up to 6, and here's the key is that one of those numbers has to be the same, right? This number is going to be in the 5 number and in the 6 number, and then these two numbers are going to add to be 3. So if I look at the numbers that are the same, in other words, if I say 5 is going to be in that box, do my other two numbers add up to 3? That would be the 0 and the 1, and they do not. What if I put a 4 in the box? Well, with a 4 in the box, the other numbers do add up to 3. So let's try that as a solution. If I put a 4 here and a 1 in this box, because 4 and 1 is 5, and 4 and 2 is 6, and 1 and 2 make 3. And so that actually works just fine. So the reason that I could solve that is because I found the one that was the same, that was just one apart from each other, and that share a number in common. So I could do the same thing on this one for the number 10 and 11. These two will add up to 10, these two will add up to 11, and the other number that's not the same needs to add up to 13. So this is a lot to ask our first graders to manage, right? But we can come up with numbers that add up to 10. And maybe we start with 0. Maybe we think, we might not want to start all the way down. Maybe we start with 5 and 5. Because 5 and 5 make 10. I won't actually go there. I know that 5 and 5 is my pair, and the other one is 5 and 6. And if 5 is my same number, the question is, do these two numbers add up to 11? Because I would be putting 5 and 5 here, and 5 and 6 there, and these two numbers have to add to be 11, and in this case, they do not. So I want to think of another pair. What about 4 and 6 that add up to 10? And I know that 6 and 5 add up to 11, and that gives me 9 instead of 13 for my other pair. Do you notice I'm going the wrong way? I had 11, I went down to 9. So what if I change the order? Instead of 4 and 6, what if I made it 6 and 4? And 4 and 7. And so that does make 11. I'm sharing the number 4, and the other number adds up to 13. So if I put a 4 and a 6 in here, it adds up to 10. A 4 and a 7 add up to 11, and the 6 and the 7 add up to 13. So by being methodical about it and finding what I have in common, and kind of what I'm using as my similar thing is this point. There's a number that I have to use to add to 10 and add to 11, and the other numbers that go with that pairing to add to 10 and add to 11 have to add to 13. That's a lot of methodology for a little guy to figure out, but intuitive ones will, and other ones can maybe find it with some flashcard numbers and the ability to kind of write things down. This is a good time to put a chalkboard out, and they can erase fairly easily and solve things like that if you've got a little portable chalkboard, whiteboards, things like that. Number 5. Yet another wagon wheel problem, a complicated nature. Just because there's a lot of options, it tells you there's more than one possible solution. What is something we could do to limit this? Well, I know the smallest number that I have here is the 4. And so I know that 4 could be 0 and 1, or 1, golly, I keep doing 1 and 0. 0 and 4, or 4 and 0. 1 and 3, or 3 and 1, or 2 and 2. Those are the only ways that I can get 4. And so I could do it that way. Another way of doing the same thing is to say 0 and 4, 1 and 3, 2 and 2, 3 and 1, 4 and 0. And actually, this is nice to do it this way because it has some more patterns later on, so I'm going to continue showing in this format. Notice I want to get the first numbers to add up to 4, the next pair are going to add up to 7, and then 8, and then 6, and then 5. So here's the deal. 0 and 4 make 4, 7 needs 3, 4 and 3 make 7, 3 and 5 make 8, 5 and 6 make 1, 1 and 4 make 5. Okay, now it'll take your student a little longer than it takes me, probably, but they can get there. Then we have 1 and 3 that makes 4, 3 and 4 make 7, 4 and 4 make 8, 4 and 2 make 6, and 2 and 3 make 5. Soon, hopefully, they begin to notice a pattern. When these numbers go up, these numbers have to go down, because again, together, they have to make 4. But while these numbers are going down, guess what's happening to these numbers? They're going to go up because they have to make 7. 2 and 5 make 7, 1 and 6 makes 7, 0 and 7 makes 7. But while these numbers are on the track up, guess what? These numbers have to go down. How come? Because we're adding to be 8. 3 and 5, 4 and 4, 5 and 3, 6 and 2, 7 and 1. Those are the options we have to make 8. And again, 5 is going down. The next column is going to go up because we're adding to get to 6. And the last number is going down because we're adding to get to 5. We know we're at the solution because I can't go any lower in these columns that are going down. I could go one lower in this one, but I'm stuck because I don't go any lower in these two columns. And I can't go any lower than 0 in that column. So I've identified all of the options. Does your student have to do that? No, they don't. We have 5 sets of answers. All they technically have to do is find one of them, but they can have fun with numbers all they want to and keep on finding it. Not a bad problem to write down in the car and let them come up with solutions and just see how many they can come up with while you're driving someplace. Number 6. This problem is similar to the number 4 that we just did. It's also similar to what they do in the example sections on number 2. They do it a very different way than I'm going to do it, and I don't say that their way is bad. I think that it is a very an abstract way to do it just because it does with a lot of letters and things. So let me just show you another way to do it. Not that one is better or worse, just another way. Sometimes you see one and don't see another, and that's perfectly fine. This is similar to what we just did, though, in number 4. So if you just tuned in for number 6, you might want to rewind a little bit and look at number 4 because we talked about it there, too. Here is the interesting point, and this tells us that the numbers adding along this way, for instance, are going to add to be 14. In other words, the two numbers on the edges will add to be 14, and then we have this line of numbers, so these two are going to add to be 11, and we have this line of numbers and have these two to add to be 13. One interesting thing to notice is that this number will add to be 13 going one way and 14 going the other way. So here's an addition that I didn't mention on 4. We're a little bit further along now. One thing I know is that these two numbers have to be different by 1, because this number is the same. If I have a number plus this is equal to 13, and a number plus this one is equal to 14, then if I go between these numbers, they must have a difference of 1, because I have to start with the same number. And then I also know that these two numbers together will add up to 11. Can you think of a number that adds up to 11 that is a difference of 1 between them? In other words, like for example, 5 plus 6 is 11. So what that tells me is 14 is going to have the bigger number. That's going to be the 6. This is going to be the 5. 5 and 6 makes 11. That works out fine. 6 needs an 8 to make a 14, and sure enough, 8 and 5 make 13. We've just solved the problem without all the guess and checking that we did on number 4. It's a little bit easier in the way it lined it up, so we can think about it this way. Same thing on this one. These two numbers add up to be 18, and these two numbers add up to be 19, and they share a number right here in the middle. So that tells me that these two numbers have to be 1 apart, and they have to add up to 15. 7 plus 8 is 15. The biggest one has to go here. The smaller one's going to go there. Obviously I have 7 plus 8 is 15. That works out nicely. I must have, with 8 and 11, and 11 and 7 is 18. Works out really nicely. If you can follow the logic, and I'm certainly not saying it's simple, if you can follow the logic, you can get to that solution pretty quick. All right, let's go on to number 7. This is a very interesting problem. It tells us to fill in the missing numbers so that the difference between any two corner numbers is equal to the middle numbers along the line joining them. This might be one your student says, how do I know? How do I know where to start? Sometimes that is just start somewhere, and what you'll find is that this is actually a very interesting problem. So for example, if we just had to start somewhere, maybe we start with a 14 up here, because 14 minus 1 gives me 13. 14 minus 8 gives me 6, and 6 minus 1 is 5. It turns out the very first one I tried worked, which makes me pretty suspicious. What if I'd started with 15? 15 minus 2 is 13. 15 needs to subtract 7 to get 8, and 7 subtract 2 is 5. As it turns out, the way they have these numbers arranged, they chose the numbers in a way that's going to make it work so that any combination that I pick is going to work just fine. What if you tried 20? 20 minus 13 is 7. By the way, it's the same thing as saying 20 minus 7 is 13. 20 take away 8 is 12, and 12 take away 7 is 5. Any number you put will always cause it to work. So same thing with the bottom one. You have to be careful. You can't put a 6 here because 6 minus 5 is 1. That's all well and good, but you can't. Well, actually you can. What do I subtract from 6? And that would be a 15. And 15 minus 1 is 14. It doesn't matter where you start in the problem, you will always be able to find it. I was thinking we should always start with the biggest number, but actually it doesn't matter. So this is just a unique problem to give you a chance to look at with your child and say to your child, look, put any number you want to in. And when you solve it, you will end up with the right answer each time, because 10 minus 4 is 6, 19 minus 4 is 15, and 19 minus 10 is 9. When you find the difference between any two corners, it's always the middle number. The reason that works every time is because they gave us numbers in the middle that will work. Since 9 and 6 is 15, since 5 and 8 is 13, and since, I didn't draw these lines, did I? But since 5 and 9 is 14, that's going to cause this to work. And it's just a little discovery problem to see what's going on. We're not going to learn any big math concepts from it, but sometimes it's interesting to play with numbers and realize that amazing things are true. Number 8. This problem is just like the others we've done, only it's drawn in a different pattern, different diagram. We have 3 digits in one way that are supposed to add up to 10. We have 3 digits in a different direction that add up to 10. If you go back and pull out or make new flashcards with the numbers of 1, 2, 3, 4, and 5 on them, just scraps of paper or 3x5s, whatever, and line them up. How can you make 10 out of that? Well, if I have a 5, I'm starting to learn about tens. 5 needs 5 to make a 10, so a 5 and a 3 and a 2 would work. A 5 and a 4 and a 1 would work. The 5 is a number that is used both places, and it doesn't matter, there's lots of options of how you fill in the numbers, but as long as you have 1, 4, 5 in a line and 2, 3, 5 in a line, you will have groupings that add up to 10. Number 9 takes the same idea and makes it a little bit more challenging, because in this particular scenario, we have a set of 2 numbers that are going to add up to 7, a set of 2 numbers that add up to 7, and a set of 3 numbers that add up to 7. And we're going to use cards with 1, 2, 3, 4, and 5 on it. If I want to add up to 7, I know that 2 and 5 add up to 7. I know that 3 and 4 add up to 7. And if I want to find another grouping, since 5 goes with 2, I can't use 5 to make 7. 4 goes with 3, but I could also use 4 and 2 and 1 to make 7. So then we can notice that I have a 2 that's used twice, and so I could put the 2 and the 5 in this way, and then notice that I have a 4 that's used twice, so the 4 and the 3 could go here, and then across the blue line I have a 4 and a 2 and a 1. So sure enough, this one is 7, this one is 7, and this one is 7, and I found all my options by using my cards and trying to put 2 cards that give me 7, and another pairing of 2 cards that give me 7, and a pairing of 3 cards that give me 7. And I think by putting some cards down, it'll help you to see what can work out easily. All right, last problem on this set, number 10. This problem, we're trying to find the sum of 9, and there's going to be 3 different groupings of 3 that are going to add up to 9, and so I want to find those. I usually start with the top one. 5 and 4 make 9, but I have an option of a 0 with this set of numbers, so that one will be a good solution. I could also have 5 and 3 and 1. If I tried to do 5 and 2, I would need another 2. I don't have a second card with a 2 on it, so that won't work anymore. But I know that 5 will work in 2 directions. Then I'm going to try the number 4. 4 and 3 make 7, and 2 more make 9. So I now have 3 groupings of 3 numbers that add up to 9. And notice the 5 is repeated, a 4 is repeated, and a 3 is repeated. So I just had to put them in my numbers carefully. Let me get rid of these colors so they're not in our way quite so much. For one of them, and I know the corners are going to be 3 and 4 and 5, so 0, 1, and 2 are going to be in the middle. I could even put that down. I suppose that might be a good starting place. If 0 is in the middle, it's because 5 and 4 are on the other sides. 4 goes with the 2 and puts a 3 in the corner, and 5, 3, 1 works just fine. Now, as it turns out, really I lucked into that one. If I had started with, have the 0 there, if I had started with the 4 down here and the 5 up here, I would realize that 4 and 1 don't have a combination. I have to have the 4, see I had a 2 here too. I have 4 has to be combined with the 2, so there's only 2 options for the 0. If the 0 is in the middle, I have either a 5 at the top or a 4 at the top. And I want the 4 to be paired with the 2, and the 5 to be paired with the 1, and the 4 and the 2 come with a 3, and that makes all of my pairings work. Sometimes it's harder to say it than to just see it and do it. Once you find these 3 pairings, and you know that you have corners of 5 and 3 and 4, which means 0, 1, and 2 are in the middle, and you could put them all in and make them all work so that all of the sides add up to 9. Of course, when you're through, you would always want to check and make sure 5 and 0 and 4 is 9, 4 and 2 is 6, plus 3 is 9, 5 and 1 is 6, plus 3 is 9, and you just want to make sure that you did it correctly. And that is the end of the recording for those challenging word problems.